Alright, time for exercise 35. Now, the first time I recorded this, I had somehow pressed stop on my recorder in the middle of the explaining, and so that video is complete trash. However, there was sort of like, it was a blessing in disguise because I realized that I had made an error in my proof. So, here's a proof of this that does not have any errors. At least, not that I know of. I first claim that FG is absolutely continuous on AB. This is going to be a really explicit proof. There probably is a simpler proof that doesn't use deltas and epsilons like mine does, but anyways, here's the epsilon proof. Let epsilon be greater than 0. Since F and G are absolutely continuous on A to B, well, they are continuous on a compact set. So then their norms are bounded uniformly by some, say, m greater than 0. Also, for all, we've been given epsilon greater than 0, so then there exists a delta. Let's say we have a delta F and a delta G greater than 0. And these are such that for all A1, B1, all the way up through AN, BN, disjoint intervals in AB, if the sum from 1 to n of bj minus aj is less than delta f, then we can choose this such that the sum from 1 to n of f bj minus faj is less than epsilon. We can do that for arbitrary epsilon, so in this case, let's actually do it for epsilon over 2m. And likewise, we can do the same thing for capital G. If this sum is less than delta G, then the sum of these things is also less than epsilon over 2m. So now, let delta be the minimum of delta G and delta F. Let's draw a delta that looks like a delta. Then sum from n equals 1, blah, 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 is less than blah, blah, blah. This will imply what? This implies that the sum, nope, there we go, sum from 1 to n of f of bj, g of bj, this product, minus faj, gaj, is less than or equal to, we'll use a triangle inequality on the inside, f of bj, g of bj, minus, and now here we interchange the, we add and subtract a term where we've got an aj and a bj involved in the terms. And so we've got this, then I'll continue this on the, there's really no good way to do this computation. So let's just do this like this, plus faj, gbj, minus faj, gaj. There we go. And then, whatever, let's just do it over here. This is less than or equal to sum from 1 to n of m. So we bring this GBJ out front, and we note that it is bounded by capital M, and so we have this so this should be FBJ minus FAJ, and then we've also got the plus M times, and this time we bring the F out, and so we get GBJ minus GAJ. But now these M's all come out front, and we can split this sum up because this is a finite sum, and so this thing, we're going to have the sum of this, and then that we know is less than epsilon over 2m, and so this whole thing is less than, let's see here, we've got the m comes out front, and then we get the epsilon over 2m, and then we get the same thing for the other term here, and then, well, this is just epsilon. So, hence, FG is AC on AB. Okay. For the equation, here, let's scroll up a little bit. By the fundamental theorem of calculus, specifically, the theorem we're citing here is Theorem 3.35c in Folland. You've got f of x, g of x, minus f of a, g of a, equal integral from a to x of fg prime evaluated at t dt. But we know that fg prime is equal to fg prime plus gf prime. And this is like one of the first things that you learn in calculus, but it's also one of those things that you need to reprove once you start to like go through real analysis and like actually prove all of these things that you learned in calculus rigorously. And so this is let's see here. If you actually need to see the rigorous proof, which is not necessarily something you might have on your fingertips, but is something that would be good to have on your fingertips, then you should see Baby Rudin, and of course by that I mean Principles of Mathematical Analysis by Walter Rudin, and that's Theorem 5.3. Hence, with x equals b, we have, and then what do we have? We have fb gb minus fa ga is equal to the integral from a to b of fg prime evaluated at t dt, which is equal to what? The integral from a to b of fg prime plus gf prime evaluated at x dx. And what is this? This is exactly the thing that we wanted to prove. And this means that we are done. And I didn't have any errors recording this, so that's a wrap.